Welcome to a deep dive.
Great to be here.
We've got a really interesting source today. It's an excerpt discussing differentiation in food security.
Right. Which, might sound like two totally separate worlds at first.
Exactly. But the specific thing our source highlights, and what we want to unpack in this deep dive, is this connection it makes to modeling sugar crystallization rates.
Yeah, specifically within that food security context.
So our mission really is to dig into that link the source points out. It's kind of surprising.
Definitely. And it shows how, let's say, sophisticated math pops up in places like food science. Unexpected relevance.
Okay, so let's unpack this a bit. The source doesn't just vaguely mention it, right? It draws a direct line. Differentiation in food security, leading straight to modeling sugar crystallization rates.
It's very specific, pinpointed, really.
And what's, I think, so powerful there is seeing a concept like differentiation.
Which is all about the rate of change, how things change over time.
Right. Seeing that applied to something so, well, physical, tangible, like sugar crystals forming in our food.
Mm-hmm. Because that crystallization, it's not static, is it? It's a dynamic process.
No, absolutely not.
And controlling the speed, the rate of that change, that's actually crucial for the quality, the stability of the food.
So thinking about rate of change, how does that actually, look in a product? Because differentiation, you learn it in calculus class, maybe.
Yeah, it seems abstract.
But here it is, helping understand sugar crystals. I mean, if you've ever had, like, grainy fudge.
Oh, yeah. Or ice cream that gets icy.
Or candy that just loses its texture.
Yeah.
It's often sugar crystallization gone wrong, right?
Uncontrolled.
Exactly. And being able to model this using differentiation allows food scientists, manufacturers, to predict how fast it'll happen.
Under different conditions, presumably, like temperature or ingredients.
Precisely. Temperature swings, different formulations. It gives them a tool to get, control. Real control.
So it's not just knowing that it happens, but how and when.
Right. They can design recipes, processes to stop the bad crystallization, keep fudge smooth, keep ice cream creamy. It's about consistency then, and predicting stability.
Over time, yeah. Which, if you zoom out...
And to think about the bigger picture.
That's where it links back to food security, in a way. These mathematical tools, they're not just academic, they're vital for large-scale food production.
Because consistent quality, reliable shelf life, that matters hugely for supply chains.
Absolutely. Minimizing waste, ensuring products meet standards when they reach people everywhere. That reliability is sort of a quiet part of food security.
Knowing it'll last, knowing it's what it should be.
And this application of differentiation, it gives a level of insight you just wouldn't get otherwise.
Now, the source excerpt itself, it points this out, but it doesn't give us the actual equations, does it?
No, it focuses more on that the math is used and where, which is fine for this discussion, I think.
Yeah, the key takeaway is that conceptual bridge, right? Seeing this sophisticated math modeling a complex food process.
That's the core idea.
So let's bring it back to the listener. What does this specific insight mean for you?
Well, if you're learning differentiation, maybe in school or college.
Or even just curious about where math shows up.
This is a concrete example. It's, a shortcut to seeing its value outside the textbook.
In a place you might not expect, like your kitchen, pantry, or freezer, that rate of change stuff matters there too.
Definitely does.
Okay, so to quickly recap our deep dive based on this source, we found this clear link. Mathematical differentiation connected directly to modeling sugar crystallization rates.
And saw how that plays a role in food quality and ultimately touches on food security.
It really just underscores how mathematical thinking is kind of hidden in plain sight in our everyday world.
Embedded in surprising ways.
Absolutely. So here's a final thought for you to maybe mull over. Building on this unexpected link.
Okay.
How many other processes, things that affect the texture, the stability, the quality of the food you eat every day, how many might be quietly governed by complex math concepts, maybe ones you're learning right now, without you even realizing it?
That's a good question to ponder.